So as you can see, when we try to call the size property, it gives us a 0. That is because all the properties have a default value. The size gives you a 0, the string probably gives you an empty string, the chart gives you an empty character and all that. So we need to set the size of the properties usually. So in order to set the size, what you do is that you call the set size method. So you call the set size method say you might give it maybe 34, size of 34. When you run this, what happens is that this 34 will now be put here. So anytime you need to use the size, you'll be using 34. So if you were to do this and you save it, and you go back and you compile it, and you try to run it, it gives you 34. So this is now the size of this object that sits in. So the same for the name. Let's see what the name gives us. Initially, what the name was default. So if we compile it and we run it, it gives us a null. This is the default value because a string is actually not a string is an object. It's not a native data type. It's not what we call a primitive data type. It's a non-primitive one. Usually non-primitive data types are objects in memory, and they come pre-installed with the JVM. When you install the Java JDK in your machine, it's inside as one of the predefined classes. So when you don't specify a value to it, it defaults to null. So that's really what classes, that's like a 0 for classes and for objects and all that. So we can give a name to that value. We can give it a name like, so here we'll change the size to name. So we change this to maybe John. And then we try to print out the name here. So if you were to compile and run this, you'll see it is now John. So this John now, for this particular object which you created here, because this object, you take, what happens is that you take copies of it for your own jobs, and this copy you take here, it's a copy of this. This is like a blueprint which you've written here, and this is like, if you create another one, and we will call it OB1. These will be another copy. People choose the same blueprint. So this is really just text written here to define how an object will look. So it is stored in memory, and each time you want to create an object, it goes there, takes this, then it uses it to create its own object that specifies this blueprint, uses this blueprint, and it creates. So this one has taken its own blueprint and done like building different houses using the same plans. They are not the same houses, but they look exactly alike, but they will have different sizes of different things, but the plans will be the same. The pillars will be in the same place, the floors will be, but they may have different sizes, and they might look different, but you will know they come from the same plan. So this John, for this particular object, its own name property has been changed to John. You can change this one's own size property and name property for different using this will be a Purubi one, then you have one. So you might ask that what is now, since we can do this, why do we need a get properties? Because we can get in indirectly, because that these get properties and set properties, they offer some protection, because these programs, they are usually shared among people to work with. So when they are shared like that, it is better when they are given these values to work with rather than these ones, so that you can create certain things here that maybe for here now, from this name now, this size, you might need this size to be less than 100. If you were to give them this, you could simply equate this to, for instance, if you say you see you can also change this, you can change the size using this. And just equal to 101. If you were to compile this, and run it, you see that it has been changed to 101. So now that is a problem, because you don't need the enter, you want it to be maximum around this. So the best way to do that is to create a set function. So you could say something like if s, later we'll talk about control statements, if s were less than 100, then you could set it else. Now for this else, you cannot provide a warning that this thing you put here is greater than 100 or 100. You have to let it be less than 100. So that is why they use this set and get methods, so that you don't have to change them directly. And also for the get method, it's probably usually so that maybe they may probably the same thing to return it. So when you return it, so since you can't change them here, you provide something like maybe private. This word private is a keyword in Java. It means that you can't change this in outside of this class here. For instance, if I were to save this, and you said I would try to change it here, if I were to run it, it will give us an error, compile time error. It says that size has private access, so it's not possible to do this, which protects size, so that you can only do it inside here. because it has public access. So you can provide those controls, say if s were less than 100. Saying in the real world, sometimes you don't get higher than certain values, Then if we're less than that, you cannot change it. If not, there's a keyword with else. So else you can provide a warning that you can't use that, and maybe reset it. So that is the real reason for that. So when next we do this, I'll be talking about string, Java string.